Hi there. Thanks for joining us. This is Space Nuts, where we talk astronomy and space science. My name is Andrew Dunkley. Great to be your host, and I hope you can stick around a little while. We've got a lot to talk about today. NASA has unveiled a new toy for Instagram users, augmented reality. So we'll be talking about that. There's an astronomical illusion with a Star Trek connection that you might find interesting and maybe a little bit disappointing too. And the first pictures from the Euclid Space Telescope have revealed orphan stars. Yep, they're out there, they're by themselves, they've got no friends, mum and dad left them. It's not very pretty. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me once again is his good self, Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Very good to be here. Very good to be still astronomer at large.
Yes, indeed. And good to see you. I hope all is well. Let us get straight into it. I was quite pleased to see that NASA is continuing down the social media road and have unveiled a new toy, which I think a lot of people, particularly Instagram users, will enjoy greatly. And you remember some time ago we talked about those sonifications that NASA released, where they took an astronomical photograph of some kind and they put musical sounds to the images. And it was designed so that the visually impaired could listen to the universe or listen to an object through the various sounds. And it was just a huge hit. It was a big, big hit, and it sounded amazing as well. Well, this is the next step, I suppose, where they're offering people the opportunity to see these amazing things out in the universe, places we'll never get to go. And up until now, we've only been able to see them in photographic form on a 2D platform. So this takes it to a whole new level.
It does. It's fantastic because what it does is it combines different frequencies of observations into images that allow you to really sort of interpret very much what's going on in this selection of objects. So there are 4 objects that have been selected. One is the Vela pulsar. Now, that actually has direct connections with Australia, Andrew, because the Anglo-Australian telescope, where I used to be astronomer in charge, was the first telescope to detect the Vela pulsar in visible light. And a pulsar, of course, is, we now know, it's a spinning neutron star beaming out radiation like a rotating lighthouse. It was known as a radio source, but it was also then detected probably in the early 1980s, if I remember rightly. It was detected by the Anglo-Australian telescope using some of the instrumentation that I later used as well. So a nice connection there. The Vela pulsar, the remnant of a supernova, I can't remember when it detonated, but it was a long time ago. Then moving on, the supernova remnant, another piece of debris from an exploding star. This is the one observed by a person we call Tycho Brahe, but he would have called himself Tycho Brahe. And he observed this, if I remember rightly, it was 1576. I just heard a bit of sonification there of what.
Yeah, that's what it was, actually. I was just looking at it on Instagram.
I thought it might be.
There it is. Sounds good, doesn't it?
Doesn't it sound great? Yeah.
Yeah.
So the supernova remnant, Tycho supernova remnant, is as I said, it's from an exploding star. It was visible in daylight. I'm pretty sure it was 1576 because it was one of the things that set young Tycho Brahe on his journey to astronomical stardom. And so that's one of them. It's got a really curious appearance. It's because it's a fairly recent supernova remnant. It's not millions of years old. It's only, 400 odd years old, or getting on for that. 400 odd years. 350 is probably a better guess. Is that right? Anyway, never mind that. It's the remnant that is being recent, it's got a lot more detailed structure in it. It looks almost like something like a bubble that's in the process of exploding. And then the Helix Nebula, very, very famous object. Again, this is actually a planetary nebula. It's the remnant of a star that has thrown off its outer layers. It hasn't exploded, it's just shed its outer layers. And one day the sun might look like this. Again, a connection with the Anglo-Australian telescope, because the first full-colour image of the Helix Nebula in perfect representation was taken by my friend and colleague David Malin, again back in the late 1970s, early 1980s, and that showed it in its true colour, as it would look if our eyes were millions of times more sensitive. And finally, the Cat's Eye Nebula, again a complex remnant of supernova activity, beautifully portrayed in these multi-wavelength images. And the images take data from X-ray, from the Chandra spacecraft. They take data from NASA's Hubble telescope, and basically various other frequencies of radiation. So we've got a very complex and detailed set of images, and how lovely to be able to use the data that were collected on these to reconstruct what they would look like in 3 dimensions and produce this portrayal.
Oh, it's amazing. And I must confess that NASA has really learned how to take advantage of social media, because their Instagram page has 98 million followers. So, and when you're in the business of trying to sell science and sell space exploration, that's a pretty good effort, I must say. So, worth checking out.
Better than the 23 we've got.
Is it that many? Mum must have joined.
Yeah.
It's terrific. And if you do want to check it out, you can go to the NASA website. There's plenty of news images about it as well. And, of course, NASA on Instagram. They've got multiple Instagram pages, actually, but the NASA main page is probably the best place to start. Now, Fred, this is kind of augmented reality as well in a roundabout kind of a way. And if you're a Star Trek follower, then this will be of interest to you, but it also might just be a tad disappointing. It looks like the star that was the home of the planet Vulcan has now been revealed to be without a planet Vulcan. What's going on?
Yes, you're right. It's a star whose name is 40 Eridani A. Eridanus, a Southern Hemisphere constellation. 40 is what we call a Flamsteed number. It was basically allocated by John Flamsteed, the first astronomer royal in the end of the 17th century. And it's a multiple star system, which is what the A stands for at the end. Now, it has another name, which I'm going to use for this discussion, and you'll see why in a minute. It's called HD 26965, and HD is the Henry Draper catalogue. 26965 is its number in that catalogue, and the reason I'm choosing that is because the planet that was thought to be in orbit around 40 Eridani A, aka HD 26965, that was designated as HD 26965b. It's how you designate planets. You stick a B after the name of the star for the first discovered planet, and then C for the next one, and etc. 26965b was discovered, or thought to have been discovered, back in 2018. And it was discovered by the Doppler wobble method, which means that scientists were looking at the line of sight velocity of the star, what we call the radial velocity, and watching how it changed with time, because that's one of the ways to discover planets. Planets tend to pull their star slightly out of place as they orbit around the star. And so what you get is a motion of the star itself around the thing we call the barycenter. That's the center of gravity between the star and the planet. And so that slight movement of the star can be picked up by sensitive radial velocity equipment, which we can do, routinely from Earth-based observatories. Now, that motion of the star has been reanalyzed, and it turns out let me close the loop because I haven't mentioned the Vulcan bit. In the Star Trek universe, 40 Eridani A, otherwise known as HD 26965, that is the star which has the planet Vulcan in orbit around it, Mr. Spock's home planet. And so that was an exciting thing when a real planet was thought to have been found around the star. But the news is kind of depressing in that front if you're a Trekkie. It looks like this is not due to a planet. The motions that we see in the star's velocity, the changes in the star's velocity, seem to be due not to a planet pulling it backwards and forwards, but to radial vibrations in the star itself. So the star itself is basically swelling slightly and shrinking slightly, just by very small amounts. But that's enough to put the surface of the star is giving you the Doppler shift that was thought to be this whole star moving, but because of a planet. And so it's to do with actually a science which we don't often talk about, and which Australian astronomers are very good. That's asteroseismometry, where you measure the vibrations in stars, the star shakes, which do happen in most stars, and it's a great way of investigating what's going on inside stars. They do that. In fact, our sun does it as well. I think on a period of about 5 minutes, the sun shakes slightly, swells and shrinks slightly on its surface. So it looks as though the putative planet Vulcan around 40 Eridani A isn't a planet, that there isn't one there.
Oh, that is so disappointing. But we shouldn't really worry too much, because in the movie series, Vulcan was destroyed in the
Exactly.
2009 film by the Romulan Nero, I think. I loved that movie, by the way. They made 3 in that series of films. That was the first one.
Okay.
He was a pretty deranged kind of character. Who was upset that his wife got killed by the explosion of their home star, which the Vulcans said they would be able to save the planet from, and they'd failed using, I think it was called red matter. Ooh. So Nero used red matter to create a black hole, which he drilled into the center of Vulcan, and Vulcan just got swallowed up. So and that was payback. And then he decided, well, we'll do Earth as well because they're bad people. So that's how it all went. It was all revenge and deep-seated hatred, which is always the basis of a good movie. But
good, honest alien emotions there.
Yes, exactly. He was a pretty twisted individual. Nero was played by the Australian actor Eric Bana, and he was brilliant, absolutely brilliant.
Yeah.
So even if there was a planet, there isn't any more in science fiction, so it's probably good that this star no longer has or never had a Vulcan.
Yes, that might be right. It could be right. I'm really glad that you filled in on the sci-fi side of this, because I didn't see that movie back in 2009, and I always thought I probably should have done. So it's probably not too late either in the world we live in today.
Yeah, well, the 3 movies they made in that series are the most recent, and they took it to a whole new level. And it basically started with how all the main characters began in Starfleet, and how it all sort of came about. And Kirk is portrayed as a real ratbag.
Oh, really? Okay.
And one of the great scenes in that particular film was the Kobayashi Maru incident. Remember, Kirk cheated. He was the only candidate that actually beat the Kobayashi Maru situation, and it got him offside with Spock, and they actually hated each other. So it's really well done. It's brilliantly done. And just an all-round good series of movies. But the first one, as always, is the best. So if you haven't seen it, it's still available through subscriber networks. So 2009 edition. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, to a really good story. This one talking about the Euclid Space Telescope, and this is the European Space Agency, is it not? And they've just revealed through a series of new photographs that there are lots and lots and lots and lots and lots and lots of orphan stars out there in the cosmos, and it's a bit of a surprise.
It is, yes, that's right. So we certainly in the days when I was observing stars and galaxies and things of that sort, we tended to think of the space between galaxies being pretty empty. We know it's full of radiation. We know it's full of electrons actually as well. We know there's the subatomic particles there as well as photons. But what we didn't realize was that there are also stars. Now, one of my colleagues at the Australian National University, Ken Freeman, one of this country's very best known astronomers, I do remember, because I kind of helped him do the observations, he was very interested in what we call planetary nebulae. We've just been talking about them with the Helix Nebula and things like that. These are the leftover shells of stars that have got to old age, and rather than they've not been massive enough to explode as a supernova, but they've shed their outer layers. And it turns into what we call a planetary nebula. It's nothing to do with planets. It was William Herschel who gave it that term because they looked a bit like planets, even though he knew they weren't planets as well. So planetary nebulae are known to exist, have been known for many years to exist between the stars, between the galaxies. But intergalactic stars are a new thing, at least in the kind of numbers that have been revealed by these images from the Euclid spacecraft. And you might remember, we've talked about Euclid before, but its mission is to really measure the geometry of the universe and basically give us an understanding of a deep understanding of the geometric structure of the universe, which will hopefully illuminate both dark energy and dark matter, because we know that they influence that overall geometry. So that's what its mission is, but it does that by taking images, and the images that have been revealed in this particular tranche of data are of a cluster in the constellation of Perseus, Northern Hemisphere constellation. It's about 240 million light years from our own galaxy. And it's a very large and very rich cluster. The photographs of it are beautiful. It's just a sea of galaxies there. But what has intrigued the researchers who have done this work, and they include people from the University of Nottingham in the UK, as well as I think some US colleagues too. Some European colleagues too, because as you said, this is a European Space Agency mission. What has sort of shone out in these images is this faint haze of bluish light that permeates the space between certainly the biggest group of these galaxies. And that is being interpreted as starlight, that what we're seeing is a population of stars, probably millions or billions of them, between the galaxies. And the first question that you ask, since stars form in galaxies, is how did they get there? How did this beautiful aura of light between these galaxies, which we think are what we were calling orphan stars, drifting through space without any home galaxy, how did they get to be like that? And so the suggestion that is in the paper that we're reporting on here is that the interactions between these galaxies, it's such a dense cluster of galaxies, and there's some really big ones in it, two large ones in particular, that the gravitational interactions between particularly those two large galaxies have basically pulled stars off the edges of those large galaxies and just sort of spun them into space, if I can put it that way. And so it's, it looks as though, especially because the density of this faint glow, which is caused by these orphan stars, that really centers all around these two biggest galaxies. And so it looks as though they are the source of these orphan stars. And it may be due to an interaction event that took place, I don't know, some millions or billions of years ago, but some sort of a merger event may have taken place. One other possibility is that Perseus cluster that these two big galaxies are in has, in its kind of random journeys through the universe, has collected another cluster. It's had a collision or a merger. And that would, of course, result in huge gravitational interactions that may well have caused this stripping of stars off the biggest galaxies.
So basically something happened that caused some of these stars, and in this case, it looks like many, many millions of them, to be just flung away and they're just out there by themselves twiddling their fiery little thumbs and not really doing much, but they're not part of any particular galaxy. Is that right?
Yeah, that's it. That's exactly it. And it seems, from what I've read, it looks as though it's actually billions of stars because there's enough light coming from them that, look at the images. And they're available online, these images of the Perseus cluster. I'm
looking right now. They are spectacular images.
Yeah, and you can see that haze. For that haze of stars to be visible at a distance of 240 million light years, which is where we are, it tells you that there's a lot of stars there.
Right. So that's how they know that they're stars that are not part of a galaxy. They're just sort of wandering around by themselves for whatever reason.
Yes, that's correct. Yeah.
That's amazing. Yeah. And this must be happening in all sorts of places, but this one seems to be much more significant by number than anything else we've found so far. Is that fair to say?
I think that's right, Andrew. And so yes, you're asking the right question there. Do we see this phenomenon in other clusters of galaxies? And the answer is, to date, we haven't really seen that. And it may well be that one of the reasons is that our telescopes haven't been sensitive enough, whereas this Euclid machine is very sensitive. But it also might mean that other clusters are not as rich in orphan stars as the Perseus cluster is, because they haven't had a merger, some sort of merger experience with another galaxy cluster or between the individual galaxies within the cluster that might tear off stars. So they may have had a more benign neighborhood to the Perseus cluster. I'm sure we'll see more images like this from Euclid, and we might find that that orphan stars are actually quite common in galaxy clusters.
Yeah, and maybe even our own galaxy has thrown off stars that are out there just sort of going, "Oh, Mom!" And that's...
We know, yeah, that's right. We do know of quite a number of stars that have been measured individually, which are escaping from the galaxy. They've probably been flung out by maybe a gravitational interaction with a black hole at the center of the galaxy, but they're on their way out. Their velocity is greater than the escape velocity of the galaxy as a whole.
Quite incredible. If you want to look at those images, they're at the cosmosmagazine.com website. They are really worth checking out, but I'd say they'd pop up on several science pages and astronomy pages and news pages if you want to check it out. The Euclid snaps from the European Space Agency is what some of the people are calling it. While we're talking about the Euclid telescope, Fred, there was another story, and this one's closely related. We're just talking about rogue stars, But the Euclid telescope has also revealed rogue planets in the Milky Way galaxy, which I found quite extraordinary. These are like the stars. These are free-floating planets, rogue planets that have just been ejected from wherever they originated, and are just sort of floating around in the cosmos. And they've the Euclid telescope has found several of them inside the Orion Nebula, it's quite an extraordinary find. We've talked about rogue planets before, and there's even talk that there might be a couple near us that we haven't found. Maybe Planet 9, if it exists, is a rogue planet that's been picked up somewhere along the line. Who knows?
Possibly, that's right. And you're quite right. I think the Orion Nebula was the place where orphan planets or rogue planets were first discovered quite a long time ago. But so it doesn't surprise me that Euclid has picked up more. I think I saw that story too. There's an acronym for these, and I'm trying to remember what it stands for, but it's FLOPS, and it's 2 Fs. The 2 Fs are free floating. I think I can't remember what the rest of it is. I wrote about it in one of the books, but FLOPS I thought was quite a good name for these things because they don't have they don't have a solar system. They're just flopping around in space. Yes, it may be that if the sun had an interaction with a gravitationally loosely bound object, a rogue planet or a free-floating planet, then maybe it could have wound up in a very distant orbit around the sun and be the hypothetical Planet 9 that's still being searched for.
Yeah, I saw another story about Planet 9 the other day, and there's been a new theory put forward that our solar system couldn't exist like it is without Planet 9. That's a big call. I suggest that's.
But I've talked to people who are,
because there are many that are saying, well, it's not a planet. There's just a lot of different things out there that are affecting the movement in the outreaches or outer reaches of the solar system. So some are saying there is no Planet 9. Others are saying there absolutely is, because we couldn't exist as we are without it. So it keeps going backwards and forwards, Fred.
Exactly. So I have spoken to somebody who is one of the disbelievers in Planet 9. She's a specialist in the Kuiper Belt and those distant asteroids which are supposed to be revealing Planet 9. She said she can't see any sign of it in the alignment of asteroids. She thinks it's all selection effects, as we call them.
Well, this is where it's going to be difficult, because if we never find it, people are going to keep saying, well, we just haven't found it yet. And then there's others who will say, well, we haven't found it because it isn't there. It's a catch-22, isn't it?
It's the same.
Just keep looking.
Yeah, it's the same problem with aliens. You don't know that they're not there until you'll never know that they're not there, but you will know they are there if you find an alien.
Exactly.
Same with Planet 9. Same story.
All right. Okay, Fred, that's where we're going to wrap it up. Thank you. Don't forget, if you would like to follow us on YouTube, you can click the subscribe button. If you want to follow us on social media, you can do that too. Space Nuts Podcast or Space Nuts podcast, the users group. There's 2 different Facebook pages. There's one that was created by Space Nuts followers, so you might want to join them, and you can chat to each other. It's very, very popular. And we're on Instagram and all those other places as well. Fred, thanks so much. We'll catch you very, very soon.
Sounds great, Andrew. Always good to talk.
Fred Watson, astronomer at large, part of the team here at Space Nuts. Hugh's a part of the team. His position is left, right, out. And from me, Andrew Dunkley, thanks for your company. Catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.